New cells are formed by cell division, in which one cell splits to become two cells. Cell division involves two processes. In the first, called nuclear division, the nucleus divides. In the second process, cytokinesis, the cytoplasm divides, producing two cells.
Okie dokie. So before I go over the math part, I want to go over some science. As you know from science class, cells, like human cells, bacteria cells, everything, living cells, the way they grow is they divide into two, they multiply. So if there is one cell, a time period later, like an hour later, there's going to be two. And I don't know if you remember this from science class, but it keeps dividing. So in the next time period, there's going to be 4. And then, of course, there will be 8. So cells multiply. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. I think I'm missing one. There's 8. And that's a fact. You saw it under the microscope. Now we need a way to count this using math. And our previous functions, we can't really count it using those. So I just want to show you the numbers at maybe in a column here. There's 1 cell, then 2, then 4, then 8, then there's going to be 16. You can see the pattern, etc., etc. Now, maybe we can do this sort of like our function. These are the outputs. At time 0, there's 1 cell. After 1 hour, maybe there's 2. After 2 hours, maybe there's 4. After 3 hours, there's 8, etc. Remember our little guess the function game? Well, if this is our input, our domain, and this is our range, kind of messy now. We got to find a function that matches this x and y. Well, it's not x squared because 2 squared is 4, but 3 squared is not 8. 1 squared is not 2. Okay, so we need a new function, and let me show it to you now. The function that this relationship matches is the 2 to the x function. This is called the exponent function. Excuse my writing. Okay, it's 2 to the x power. It's different from the others. Okay, and this is the only function where the x is in the exponent position, not in the base. So you can see how it's different from the other 5 that we've been studying so far. So in my next video, I'm going to show you what the graph of the exponent function looks like. Alright, let's make a table so we can start graphing the 2 to the x function. So let's make a table of values for x and f of x. Remember, f of x is y, the output. And usually we're going to we'll pick 0, 1, 2, and then maybe some negatives. -1 and -2. So the output, 2 to the 0 power is 1. 2 to the 1 power is 2. 2 squared is 4. Now for the negatives, you have to go back to algebra. Remember, what's the definition of a negative exponent? 2 to the -1 power is actually the reciprocal 1 over 2 to the 1 power. Positive, remember? So that's 1/2. So 2 to the -2, I'm running out of room, is 1 over 2 squared. Whoop. Whoop. No, I ran out of room. 1/4. Can you guys see that? Sorry. 1/4. So it's 1, 2, 4, 1/2, and 1/4. So, if I plot this, start a new one, yes, blanky. Let's plot this on an XY axis. 1, 2, 3, 4. Maybe we use red dots. Yeah, there we go. When x is 0, y is 1. Right there. When x is 1, y is 2. When x is 2, 2 squared is 4. Right there. That's 4. Right. When x is -1, it's only 1/2. So 1/2 is like halfway between the tick marks. And when x is -2, 2 to the -2 power is 1/4. It's even lower. Not really touching. But if I connect these dots, this is what the exponent function looks like. This is the new shape that you're going to have to work with. Now there's a couple of things that are different with this shape that's different from the rest of the 5. The first thing you should notice is the y-intercept is not at the origin. It's actually at 0, 1. That's our reference point. Okay, so when we shift it to the left or right, that point's going to move. Okay, and we have to draw it using that as our reference point. Okay, and there's also this line that you see. This graph is going to go lower and lower and lower, but it's not going to touch. And I think I'm going to use a red line. I'm going to draw it dotted. In the original, the x-axis is actually this line, and it's called the asymptote line. Asymptote. ASYMPTOT line. I'm drawing it dotted. That's a line where the graph, the black graph, does not cross as x goes towards -infinity here to the left. Okay? So that's one of the features of the exponent graph that's different from the rest. The y-intercept is actually 0, 1, and then there's this asymptote line that's part of the graph, and you should draw that line when you're sketching. Okay? So that's the graph of the exponent function. This is our new shape.